Today I will talk about the general circulation of the atmosphere. Through general atmospheric circulation, heat energy and water vapor are moved from the lower latitudes to the higher latitudes. Because warm air rises, this process helps to maintain a sort of balance of heat throughout the Earth. Earth receives its heat from the sun in the form of ultraviolet radiation. These rays hit the Earth horizontally. Near the equator, the UV rays are relatively perpendicular to Earth's surface. At high latitudes, these rays reach the surface at an angle. This means that the same amount of UV radiation hits a smaller area at lower latitudes, but is spread over a greater area at higher latitudes. This is why it's hotter in the tropics and colder in the poles. At low latitudes, there is a greater amount of energy because the amount of heat radiated from the sun is greater than the amount radiated from the Earth. At higher latitudes, there is an energy deficit because the Earth releases more energy than it is able to receive from the Earth. This creates an imbalance in energy and is one of the two causes of general atmospheric circulation. The second cause for general atmospheric circulation is the Coriolis effect, which is a force created by the rotation of the Earth that acts clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Warm air rises from the equator toward higher altitudes, then falls down back toward lower altitudes. As we know, the Earth rotates, so when the warm air from the equator rises and the colder air from the higher latitudes falls, the Coriolis effect causes the flow of air to bend right. (0 degrees and 60 degrees latitude are considered to be low pressure zones where the air currents rise and there is a greater amount of precipitation. 30 degree and 90 degree latitudes are considered to be high pressure zones with descending air currents. Because of the Coriolis effect, three cells of circulation are formed and cause trade winds, the westerlies and the polar easterlies on Earth's surface. 0 degrees to 30 degrees latitude, there are Hadley circulation causes trade winds on the Earth's surface. 30 degree to 60 degree latitude, Ferrel circulation causes the westerlies, and 60 degree to 90 degree latitude, polar circulation causes the polar easterlies. Global atmospheric circulation explains the location of world climate zones. All of these changes in circulation that I discussed transfer heat and moisture to different places, and these are the reasons we have different climates around the world. When we compare the global atmospheric circulation model to where we see different ecosystems, you are able to see patterns that appear between the different latitudes. In the Hadley cell, we see tropical climates at the equator, where there is lots of precipitation and humidity. As you move away from the equator towards 30 degrees latitude, you see desert climates, where the air becomes much drier. In Ferrel cells, the wind is pulled toward the poles and picks up moisture as it travels over oceans. Warm, moist air meets cold air at 60 degrees latitude. This causes low pressure and creates climates with unstable weather conditions. In the polar cells, the air sinks, forming high pressure zones. The cold air sinks towards lower latitudes and mixes at 60 degrees latitude to form polar fronts. The climate here tends to be very cold because they give energy without receiving much in return, and less energy means less heat.